Welcome to KhetzTutorials, and in this video I'll be covering Cramer's rule. Let's say you have a system of equations, right? And whatever definite number of equations you have doesn't really matter. The rule still applies as long as it's a square matrix. But I'll be really focusing on 2 times 2 and 3 times 3 matrices. And so the general formula or the general representation of the coefficients found in this general form of equations. So the I here represents the row and the J represents the column. So basically, in control systems, in circuit analysis, or in differential equations, whatever, you'd basically represent the system of equations as matrices. So that's what Cramer's rule is basically about. Finding the values of the variables, whatever number of variables you have, using matrix operations. So now, since I mentioned that the numbers here represent the position in a matrix, let me go ahead and split this up. So we'd split this system of equations up into an A matrix. Let's start with the 2 by 2 matrix. So an A matrix of the form A11, A12, A21, and A22, right? And these are the coefficients of each of the variables which we're interested in. And then next, you'd have x is equals to, this would be a column matrix, which consists of all the variables which you want to find. And finally, you'd have B, another column matrix, which could be constants. So for 2 times 2 matrix, you'd have B1 and B2. And the same applies for a 3 by 3 matrix. You just extend downwards one row and another column. So that's basically it. And you'd have x3 here, you'd have b3 here. So that's just a quick recap about matrices and how you represent all the coefficients. So all of this can be summarized in matrix form as AX plus B, right? Which is that matrix, and that matrix. Now it's simplified into this form. So let's say we have whatever equation or simultaneous equations. You could use quite a few methods to find the values of the variables, but it's much simpler to use matrix operations like Cramer's rule. So let's go ahead and break down how you'd solve a problem using Cramer's rule. Okay, so let me just erase this. So let's start off with a definition of Cramer's rule. So there are quite a few requirements for you to use Cramer's rule, but if you're watching this video, you probably need to use Cramer's rule. But one of the requirements is the system of equations have to be linear and linearly independent. So if you don't know what that means, you can quickly look it up, but yeah. So the general definition of Cramer's rule says to find xk, you have to divide delta k by delta, right? By delta, where k is 1 up to n. So what this means is if you have a lot of variables, x1, x2, etc., which is basically represented by k in this case, then to find x1, you'd have to find the determinant delta 1 divided by the determinant of the matrix A. So the matrix A is the matrix of the coefficients of whatever system of equations which you have. And delta 1 or delta k in general, which is delta k, when finding x subscript k, you'd have to move the b, so ax plus b, you'd have to move the b column to the k column. So this is what that means. Let me do it again. So x subscript k is equals to delta k divided by delta. So let's say I want to find x1. I'd have to move, so let's do that for this kind of matrix. Okay, let's quickly do that. Right, and I have an x column there. So basically, now the form would be ax is equals to b, and so b would be on this side, right? So this is the A matrix. To find delta, you find the determinant of this matrix, which is the A matrix. To find delta k, which is delta 1 up to 2 for a 2x2 matrix, you move this B matrix to whatever k column. So if you want to find x1, you move the B matrix to column 1, right? So you move this here, B1, B2, and then you find the determinant of this particular matrix. If you want to find x2, you move this B matrix to the second column, which is over here. So you leave this column as it is, right? And you move the B column there and find the determinant of this, which is that delta 2. So that's basically what this means. So it doesn't matter the number of variables which you have. You just have to move the B column to whatever k column which you're interested in. K corresponds to the number of variable in your column matrix. So now I'll move on to some examples to explain what I just said. So we have two equations, and we have to find x1 and x2. You can simply take x2 to the other side and take the 4 to the other side and substitute into this. But we are now interested in using Cramer's rule to solve the same problem. So now let's look at the coefficients of the variables of interest. So the variables of interest are x1 and x2. So the general form is Ax is equals to B, right? So the A matrix consists of the coefficients of the variables. So the coefficient at the top, 3, and that one there is -1. And for the equation at the bottom, the coefficients are -6 for x1 and 18 for x2. And all of this is equals to the B matrix, which is a column matrix consisting of the constants, on the other side, which are 4 and 16. 4 and 16. So we're now going to solve the problem using Cramer's rule, which says x sub k is equal to delta sub k divided by delta. So let's start by finding the delta, like the general delta. So this delta is equals to the determinant of the A matrix, right? So let's find the determinant of the A matrix. So the A matrix, as it stands, is this. So the determinant of that would be, so you're going to say the determinant of the A matrix as it stands over there. And so to find the determinant for a 2 times 2 matrix of this form, you're going to say this multiplied by that, subtract this multiplied by that. So it's going to be 3 multiplied by 18, and then minus 1 multiplied by -6. So this is 54 minus, so this is minus and minus, so it becomes a plus. This is basically 6, and that should give 48. So the determinant of the A matrix is 48, right? Moving on, we now want to find x sub k. So the first x sub k is x sub 1. So to find x sub 1, from the definition, we find the determinant of 1 divided by the determinant of A. So the determinant of, or delta sub 1, is equivalent to moving the B matrix to the first column, because the subscript here is 1. So we move this B matrix to the first column, right? So we're going to say determinant 1 is equals to determinant of 4. We now move this and then keep everything as it is. So we move 4 and 16, right? And we leave the minus 1 and the 18 as they are, minus 1 and 18. So the determinant of this, multiplying that by that, and then subtract that, multiply by that, right? So let's go ahead and do that. So we're going to say 4 multiplied by 18 minus 1 multiplied by 16 to find the determinant 1. Determinant 1 is equals to 72. So this is going to be plus 16, which is equals to 88, right? 88. So now we go back to this formula and we plug whatever we found. So we said xk is equals to delta sub k divided by delta. So we now have delta 1 and the delta. So delta 1 is 88 and delta is 48, right? So this is how we find x1. So x1 is therefore equals to 88. Let's punch that into a calculator. 88 divided by 48. And the answer is 1.833. And now finally, we move on to find x2. So x2 is equals to delta sub 2 divided by delta. So delta sub 2 simply means we move the B matrix to the second column and leave that as it is. So delta 2 is equals to, so move B to the second column, so we leave the first column as it is from the A matrix, and we move this to the second column of the same matrix, and we now find delta 2 to be 3 multiplied by 16 minus 4 multiplied by minus 6. So this becomes this becomes 48 plus 24, which should be, so that's 68, and then that should be 72, right? And moving on to find x2. So x2 is equals to delta sub 2, which we found there to be 72, divided by delta, which is still 48. So that divided by that will give you x2. And the answer to that is 72 divided by 48. The answer to that is 1.5. 1.5. And that is how you solve these equations using Cramer's rule. So for the next example, we have 3 equations. So you'd expect to find a 3 by 3 matrix. And that is exactly what we're going to have. Just to remind you, we have AX is equals to B. So the A matrix will consist of all the coefficients of all the variables. So starting from the top, 3, -1, -2, that's the A matrix. -1, 6, -3, -2, -3, and finally 6. Then we're going to have the X column, which is X1, X2, X3. And we're going to equate all of this to the B matrix, which consists of these constants. All right, so that's going to be 1, 0, 6, So now you want to solve this system of equations using Cramer's rule. So nothing is changed from the general formula of Cramer's rule, but there is quite a twist to find the determinant of a 3 by 3 matrix, and that is basically the only change which you'll notice. So there are quite a few methods which you can use to find the determinant of a 3 by 3 matrix, but I'm going to show you my method, the method which I basically use. So let's start off by finding, so let's recap. Cramer's rule says this, right? So if you want to find x1, you move this column to the first column. If you want to find x2, you move this to there. If you want to find x3, you move this to there, and find the determinant at each of the points. Now this determinant at the bottom is basically the determinant of the A matrix as it is, right? So let's continue. So first I'm going to find the determinant of the matrix as it is. So determinant of the A matrix as it is right now. So this is what we're going to have, determinant of this as it is. Okay. Right. So this is my method. This is what I do. So I start at the top left corner right here, and I cross this out like that. So when you cross this and that out, at the point of intersection of those two lines, you have this number here, which is 3, right? So you're going to say 3. Let's come down here. You're going to say 3. And after crossing this and that, you're left with this 2 by 2 matrix in here. So now you say 6 multiplied by 6. So 6 multiplied by 6, and then minus 3, negative 3 multiplied by negative 3. So after crossing that, just a recap, after crossing that, so going crossing that, right, you're left with this in here. So we find the determinant of that, which is 6 by 6, subtract negative 3 multiplied by negative 3, right, and then you close the bracket. So this 3, you found this 3 from crossing out these two lines. The point of intersection is the value which you take. And now for the next term, you say negative, and you cross out the next part of the same matrix. You're going to cross out there and there, right? And here, let's read out again. You're going to have 3 minus 1 minus 2. So now, after crossing out this, you are left with, so at the point of intersection, you have negative 1 at the point of that intersection of the two lines. So you have negative 1, you write it down. And now in here, you look at the 2 by 2 matrix, which is formed by crossing out. So it's minus 1, minus 2, minus 3, and 6. So the determinant of that will be minus 1 multiplied by 6, minus 1 multiplied by 6, and then minus negative 3 multiplied by negative 2. And now finally, you say plus, and then now you're going to cross the last part of the matrix. Finally, you're going to say you cross that part, and you're going to have this matrix remaining, this one here, the smaller one from this side. Now, at the point of intersection, you have minus 2, so plus minus 2, right? And you're going to have minus 1 multiplied by minus 3, minus 1 multiplied by minus 3, and then minus 6 multiplied by minus 2. And then just basically punch this into your calculator to find the delta of the A matrix. And the delta is, punching this into a calculator will give you the determinant as 39. Right? Moving on to find determinant 1. So basically, as the rule says, the subscript matches where you actually put the B column. So the subscript here is 1. So we're finding the determinant 1. So we move this B column to the first column of the A matrix. That is basically what I did here. And finding the determinant of that, you just basically apply the same rules. So cover the first part with a line there and a line there. At the point of intersection, you have 1. Hence, I have 1 in there. And after covering both these sides, you're left with this small matrix here. So the determinant of that, you're going to have 6 multiplied by 6, and then negative 3 multiplied by negative 3, which is basically what we have here, and then negative, and crossing this part at the point of intersection, you have -1, so there's -1 over there, and after that you're left with this matrix. So 0 multiplied by 6 is basically 0, and then what you have after that is -3 multiplied by 6, which is over there, and finally you cross out this last part here, and you're left with this matrix in here. So you have 0 multiplied by 3 minus 6 multiplied by 6. And you take that point, which is the point of intersection of the last two lines, and you plug it there and everything else. After punching that into a calculator, this is what you get. Moving on to determinant 2, you basically do the same thing. The subscript matches where you put your B column. So this is determinant 2. So you put the column B in row 2, in column 2, of the A matrix, and you find the determinant of that, doing just basically the same thing, taking that, and then doing the determinant of the small 2x2 matrices, which form after performing all of that. This is what you have. And just simply putting that into a calculator will give you 78. Right? So let's move on to finally find determinant 3. Right? So let me erase this part. So let me just save all of these answers up here. So the main determinant, which is the determinant of the A matrix, we found to be 39. And determinant 1 we found to be 117, and determinant 2 we found to be 78. So let me erase this first part to create some space. All right. Now finally we're going to find determinant 3. Right. So the subscript matches where we put the B column. So in this case we're going to put the B column at the third column, so 106, that's the B column, and then everything else from the A matrix remains. So that's 6 and 3 minus 1 minus 2. Now the determinant of that, so you cross the first part, at the point of intersection you have 3, and this matrix which remains is going to be 6 multiplied by 6 minus 0, because 0 multiplied by -3 will give you 0. And you say minus, and then at this point of intersection you have -1, and you're left with -1, 0, -2, and 6. So -1 multiplied by 6, -1 multiplied by 6, and then subtract 0, because 0 multiplied by -2 will give you 0. And finally we have +1, which is the last term there, and you're left with this matrix here, which is the small matrix. So -1 multiplied by -3, -1 multiplied by -3, and you subtract this, which is 6 multiplied by -2. Right? So let me just quickly punch that into a calculator to find determinant 3. And so here it goes. We have 3 multiplied by 36, which is the first bracket, and then we have plus -6, so -6, and finally we have, this is 3 plus 12, 3 plus 12, which is 15. And the final answer is 117, which is basically the same with determinant 1. Determinant 3 is also 117. So finally, we want to solve the problem. So let me erase this part. You want to solve the problem. So Cramer's rule says, if you have a variable x sub k, you divide the k determinant by the determinant of the A matrix. So that's basically what we're going to do to solve the problem. So this is what's going to happen. So x1 is basically equals to determinant 1 divided by the determinant of matrix A, and x2 is determinant 2 divided by the same matrix, the same determinant of matrix A. And finally, x3 is determinant 3 divided by that. So just plugging in the values which we found by finding each of the determinants, we have 117 divided by 39. We have 78 divided by 39. And we have 117 divided by 39. So these should give you 3, 2, and 3. So x1 is equals to 3, x2 is equals to 2, and x3 is equals to 3. And that is how you solve this system of equations using Cramer's rule.